Hey everybody, this is Matthew from Bill's Gaming here, and we are starting a new series called Game Development. And, well, I mean, right now it's not really game development. I'm going to have to teach you something first. I'm going to have to teach you C. Partially because I don't find that there are a lot of C tutorials out there online. It's basically just C++. I think the new Boston has a C tutorial, so if you don't like this one, check that out. But I just wanted to make a pretty good C tutorial because I'm really disappointed mostly with basically a lot of the C tutorials that are out there, and other than that I just wanted to do something different than just playing games and stuff. I wanted to do something like, you know, real serious. I mean, I guess we're kind of competitive in some games, but anyways, we're going to be doing a game development series. We're starting off with learning how to C, and I'm going to teach you youngins how to do this right, how it's proper and right. First things first, we're going to have to shit. Is caps lock on? Okay, it's not. Okay. All right. First thing you need to learn about is preprocessors. Preprocessors are things handled by a C document. Oh shit, this probably makes no sense to you at all. Alright, let's dial it back. I'm not gonna cut that out. Let's dial it back. And we need to have some mistakes in here. It's gonna be lots of mistakes, but at the same time it's a learning experience for me as well. So, I'm assuming what I just said, I'm basically sort of assuming that you had some knowledge of programming before, and I probably shouldn't be doing that, and I will say that I'm not sure what level. It's hard to say when you are a programmer what level you need to start at when you teach people about programming. I guess I could have continued from there, but I think we're gonna just delve right into what I was gonna say, and I'll try to explain things as much as I can, basically, what I'm doing when I'm writing this is writing lines and lines of code for the computer to execute line by line. Like, this right here is a command. Oh shit, the caps lock is on. Son of a bitch. Alright, there we go. Alright, I'm making basically just a line of commands. That would be, let's see, include standard. And that's basically a command. You don't have to know what that means for right now, but I'm going to tell you that this right here is the basis of most of your C programs. It's probably going to have this in it. First of all, I'll explain it in a second, actually. I'm not going to just leave you in the dark. That's kind of one of my problems with some of the C tutorials out there, is they just sort of leave you in the dark. They leave you in the dark. They just tell you, oh, this is a C program, and you need to do this. I'm not going to tell you why, but you need to do this, which is my problem about that. So I'm ranting about how much I don't like some of the C tutorials out there, but I'm going to just do my own series. All right. So this right here, it's very C is very it's very intuitive. So when it says include, it means that it's including in this one file, and in this file called teaching.c, it's including the standard io.h, and that's the file extension. This is another thing I want to cover. This is a file extension. Like, you know how you have a little bunch of if you have a game, if you play a lot of games, you'll see like .exe or something. That's a file extension. This is also a file extension. This is the C encoding for files. So this is a C file. I know that by the .h that this is a C file, and that this it's kind of hard to see what this is, but it's supposed to stand for standard I/O, and I/O stands for input and output. So standard input and output. So it's basically this allows us to do this. I hope I broke that down fairly well. Yeah, I just try to use an example to explain basically the relationship of file extensions with games and stuff. If you play a lot of games, you'll see like .exe or .jar. If you play, I don't know, fucking Minecraft or something, you'll see .jar or something like that. And this right here, I need to explain this. This is something called a, it would be sort of a data type, sort of. Like, I would say, this is classed as an int, or basically an integer. And this right here is the main function. That's sort of something that not really you don't have to understand basically. And this is different from up here where I wanted to teach you what this means. This is different. This is like basically this is where main means where main is the part of the code where it starts, like I mean not where it starts, like where everything is executed. So you need this, and it should always basically be integer main. And basically it's integer main because it needs to return 0. And when you return something, it's because there's a function that needs to produce something. Like if you've done math before, a function in math has an x input usually, not multiple inputs. So in programming, functions can have any number of inputs. You can have fucking 1,000 if you want to. And in math, it's different. You really don't. It's harder to work with that in math. You have like f of x or something like that, but f of x is the output, but x is the input, right? So this right here, return, is the output of a function in math. Like if you're thinking of it in math terms, this is the output of a function. So if I were to put an argument here, you can't put arguments in main, sort of. I mean, you can, but that's for special cases. If we're just thinking about this as like a normal function, let's look at like x and y or something like that. Sorry, actually, it would be int x. You have to define the type before you just put arguments in there. It's different from other programming languages. C is older and much better than most programming languages, by the way. And it's older, but it makes code automatically. Basically, if you learn the C way to program, it sort of like if you know what you're doing, it's basically just going to make your programs run faster. I mean, a lot of programming languages other than C have a lot of automatic memory management, and that really slows down your programs, and it doesn't allow you to control or restrict, restrict or increase the amount of memory usage I need to use. And I have to go to class in like 20 minutes or so, so I have time for this, but God, I gotta figure this out. Alright, so int x and int y. Basically, if I were to put in, rather than, it would basically return, if I have x plus y, and then, well, actually, what I could do is just do this, x plus y, and that would be your output. So it's sort of like the output of your function, but it's different in that this is not, what you return is not based upon your inputs. It could be anything, especially something like main where you don't have any inputs. So you can't really return anything that has to do with your inputs, or like you can't have like 3x or something. F of x equals 3x. You can't do it. I mean, you can do that, but it's not based. They're not tied together. Your return value is not tied to your argument. They're independent of each other. It can be used for that, but it's still like the output function of a I mean, it's like the output part of a function. Alright, so we're crawling here, but I'm trying to explain this as slowly as possible so everybody has a firm grasp of what I'm trying to say. Let's move on to data types real quick before I have to go. Here is what an integer is. An integer is a number between like negative 2 fucking billion or something like that. I don't know. To negative 2 billion something. I can't remember. I cannot remember, but it's negative to positive. And you can only make it that. Like a computer cannot understand. It doesn't go infinitely. If you typed in a number that was larger than an int, basically an int is the basic. It's the basic. How do I say this? Fucking seriously. It's the basic number sort of thing, and unless you use unsigned or signed integers, it won't increase. It's hard to explain. God damn it! Like you cannot put a number in for an int. Like if I put int x, fucking I just should have done this from the beginning. Integer x is equal to that will not work because that is way too fucking big. I know I'm not sure what the number is that is specifically that it actually can't hold, but I know for fucking sure it can't hold that. An int would be something like shit. Okay, an int would be something like this: integer equals 7 or something. It doesn't have to be that small. It can be like 1,000 or something like that. I don't know, but it cannot be the difference. One thing that's different about this is it cannot be a decimal. Remember that an integer cannot be a decimal. If you add something like to a decimal, I don't want to do this, but I'm gonna screw this up in explaining it. But if you put a decimal in here, 7.9, you might think, well, if it can't be a decimal, what's going to happen is it's probably going to round it. No, it doesn't round it. It just gets rid of the decimal, and you're left with 7. It's just sort of like it pulls off the decimal, just like it's not there anymore, basically. Yeah, I am explaining this so poorly. But anyways, it just gets rid of it. If I were to compile this, let's compile this actually. And we're going to do another statement, which I'm going to explain real quick, is printf. And also feel free to pause the video at any time. I'm actually going to, speaking of the compiler, I need to actually make a video explaining how to install the MinGW compiler. Don't you worry, I will be very thorough in my explaining. It's a bitch to like compile programs now. I mean not now, it's sort of always been, but it's a bitch, and I'm gonna help you through it as much as I can, because I know how fucking annoying it is. So what we're gonna do is going to printf. We're gonna do %d. %d stands for decimal, I think, but you use it to print ints. I don't know. This is weird. And then we're gonna do /n, and /n stands for new line. Just remember that it stands for new line, and you put that in there. You put the /n in there when you want to make a new line. %d is for printing numbers. You can't just go in here and say printf. Hold on, let's get rid of this. You can't just say I'm going to print x by doing this. Printf x. What printf does, I'm going to show you. I'm going to explain to you by showing you in a second. So be prepared for that. %d is used to print the integer, and this is used to make the new line. So now we're going to make a comma right here, and this is we're going to put the x. Now you might be confused. This is basically this is a placeholder for this. If I were to add like %d again, it goes in order. It's basically sort of like it's in order. If I had another integer or another variable like a y or something, it would do first is x and then second is y, because that's how they're ordered. Other than that, yeah, get rid of that. Back that up. Alright, so we have %d/n, and we can save this now. Let's see. And now what it should do, if we go to our compiler right here, we have to change our directory to the desktop, because that's where I have this saved. This is command line. I'm not going to teach you command line. Sorry about that, but I'll just tell you that when you want to change your directory, you have to change it to where it's being compiled and where the file actually is. So this is it's on my desktop. It's just sitting there on my desktop. So that's all I'll say. So what we're going to do is we're going to do gcc. This is a mingw command. I'm going to teach you mingw. I have to install it later. It's a bitch to install. And we'll go to client.exe and compile. Shit. Okay, what did I do? Oh, sorry. Oh, shit. Yeah, that's my bad. That's a different program. I am so dumb. I should probably cut that out, but I don't think I should at the same time. That's kind of an unnecessary jump. Let's see, teaching.c -o teaching.exe. And we got an error. It's fine. We'll fix it. Missing a semicolon. That's right. That's right. We're missing a semicolon. Semicolons are how you indicate an end of statement. This right here is a statement or command, wherever you want to call it. This is a preprocessor. It does not have a freaking semicolon. Main does not have a semicolon. It's special. Everything else has a semicolon at the end of it. Int x equals whatever, when you're assigning something to a number, has a fucking semicolon. When you print something, it has a semicolon. When you return something, it has a semicolon. Okay, just remember that. So what I'm going to do is we're going to save it again. It's a mistake. No reason to cut out mistakes. It's all part of the learning process. gcc teaching.c -o teaching.exe and compiled. So now what I'm going to do is load up. Oh shit, get out of here. I'm going to load up. Where is it? There it is. Okay, so you saw how it just, there's a window that just flashed up like that. Here. What we're going to do is we're going to add, here it is, get character. And it's going to have no arguments. Get character is basically waiting for you to input something, and then depending on your input, it would output something. But if you just have no arguments, it just waits for you to put something in, and then just nothing happens. It's waiting for you to input a number in command line, or something, not a number, just anything, any character, like a character or a question mark, or a letter or a number, anything like that. So it's asking to, it's taking input. But if you don't do anything, it has to keep the window open while waiting for you to do that. So the reason why I was closing, it was just running the program, and it was outputting, but you couldn't see it because the computer's so fast. It's just gonna, print to the screen, and then boom, it's gone. So what we're gonna do is save this. Yeah, I've already done that. We're gonna recompile this. That was kind of a shitty explanation, but I'll go into more depth later. But just basically for now, it's basically making the computer wait for you, just so it can so you can input something, and the only way it will close is if you input something and then press enter or something like that. So that's how that works. Compiled again. Where is, okay? let's open this up. Now it says 7, and here if I were to input H or something like that, and now it's gone. So it was waiting for me to input a character. Hold on. And once I did that, it would close. So that's how you basically compile something and print something. And you noticed it was 7. Oh, that's another thing. You noticed it was 7, not 8 or something like that. It doesn't not, like I said, does not round. It just gets rid of this right here. Gets rid of all that. Get character waits for you to input any kind of character, like a letter or a number or a special character. We went over everything else. A function is just is similar to how a function works in math. A preprocessor includes a file, a different C file, just sort of like this one, teaching.c, sort of like that, except it has different files that allow you to do this. Standard I/O, I should have gone over this before. This is kind of, well, circular, I guess. Standard I/O is what allows us, this file right here is what allows us to use this right here. We cannot use this with we cannot use this without having this included in our document. This is basically taking that file and adding it to this file. This is what the include statement does. This file is now part of this file, God, and I just realized that this has got to be so confusing. There's really, at some level, people are going to complain probably in the comments that it's not simple enough. It's not like, there's a certain point where you cannot simplify it any more than it is, and I feel like I've done that. It just can't get any more simple. I understand that it might be confusing, and it's understandably confusing. But there's just a point where it just can't be simplified anymore. And really, you have to work at it, and you have to learn what it means. I try to explain as much as I can. If you make something an int and it has a decimal in it, it will just get rid of the decimal, just discards it. And printing something, I've really tried to explain that as well. You can print something like blah 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 or something like that. You can print something like that, and you don't have to have something like that because it's not a number. It's just a string of text, so you don't need to do that with a number. Numbers are you can't just print them willy-nilly. But you can do something like that. There's no problem with that. Semicolons and statements. Return values are not tied to your output, but they are your output at the same time. It's weird. But other than that, I think we've got a good first video going, and I think I've basically explained one of the data types. I'm going to explain the rest of the data types. I've only started with int today, but I think we're going to have to end for today. I feel like I've given you a basic explanation of how this all works. But other than that, thanks guys. Thank you guys for watching, and if you found this helpful at all, please tell me how I can make the series better. If I didn't do this very well, or if I did, please still give me your feedback. Tell me how I can make this better. Other than that, thanks for watching, and I'll see you guys next time.